The next speaker will be Andre Assis, and he will be speaking about the planetary model of atoms. And then we will have a Q&A session.
Okay. So, in the first place, I wish to thank Professor Janrak and NAMI-Tech for inviting me to this beautiful and important city of Prague. I came here 4 years ago, also with an invitation by Professor Janrak in 2019. And at that time, I spoke about Weber's electrodynamics and another seminar about relational mechanics, which is an implementation of Mach's principle with Weber's law applied to gravitation. So these things, as we will see along the talk, have some connections with Prague, which is very interesting. But the first slide, please. But today, what I will talk is about a more specialized topic, which is Weber's planetary model of the atom, which is extremely interesting, but has been forgotten for more than 100 years due to the dominance of the field equations paradigm of Faraday and Maxwell and so on. But it's extremely important, and it's coming back to life again. So Wilhelm Weber, he was born in 1804 and died in 1891. He was a contemporary of Maxwell in England. He was born before Maxwell and died after Maxwell. So this picture of the previous one, this picture of Weber, and at the height of his career, when he presented his force law, and he was a experimental professor of physics at Göttingen University, and he worked in very close collaboration with the mathematician and astronomer Gauss. They made many works together, especially in electrodynamics and in magnetism. And Maxwell knew a lot about the works of Weber. In his book, A Treatise on Electricity and Magnetism, Maxwell quotes Weber many times, always praising highly Weber for his experimental achievements. So, next slide, please. So, before I go to the planetary model of the atom, I will just present briefly here the main ideas which led Weber to obtain his equations. So in 1846, at the middle of the 19th century, when he presented his equation, he knew the force law of Coulomb, which is like Newton's law of gravitation, a central force which falls as 1 over r squared, 1785. Weber also knew the force by ampere. Ampere presents a force of interaction between two current elements, which is a force, a central force, which is also analogous to Newton and Coulomb's law, which falls as 1 over r squared, but proportional to the product of the two current. But it depends also, it's a little more complicated because it depends also on three angles. The angles between the two current elements and the angle between each current element and the straight line connecting them, okay? Alpha, beta, and gamma. But it's a similar force law as Coulomb and Newton. And Weber also knew Faraday's law of induction. The electromotive force is proportional to the time variation of the current. So this was known to Weber, and he wanted to unify Coulomb, Ampere, and Faraday. but from a different paradigm, many years before Maxwell, without field concepts. So next, please. So Weber's hypothesis was a very simple one, just that what is current? So he supposed that electric current is simply charge in motion. So the I by amperes force, the current intensity, should be proportional to the velocity of motion of the charge relative to the circuit. So he wanted to unify these three laws. If current is charge in motion, the Ampere's law should have a component like V1, V2, the velocity of the two charges in the two currents. So the middle term of his equation should be a complementary to Coulomb's law, introducing a component which depends on the product of the two velocities. If current is charge in motion, a time variation of the current should mean acceleration. So macroscopically, if we change the circuit, the current in the primary circuit, we are accelerating charge, then we produce a force in the secondary circuit, which depends on this acceleration. So that was his main ideas, very simple, no fields, just to unify these three laws. Next slide, please. So in 1846, he succeeded in unifying these three laws. That is his famous force law, which is just Coulomb's law, Q1, Q2 over R square. It is a central force, but it has a velocity component, R dot square over 2C square. R dot is relative velocity between the interacting charges. He needed that in order to obtain Ampere's force from Coulomb. And he also introduced an acceleration component term, which is these R2 dots. This is relative acceleration between the interacting particles. And he introduced a fundamental constant of nature, which he called C. Nowadays, in the International System of Units, that is 1 over square root mu naught epsilon naught. At that time, no one had not the slightest idea of the value of this constant. But then 10 years later, Weber was the first to measure this constant. And he found 3 times 10 to 8 meters per second, which was known to be exactly the value of light velocity in vacuum. So many years before Maxwell, Weber obtained a connection between electromagnetism and optics with his constant and his very famous measurement, a classic experiment in physics. Next slide, please. What are the main properties of Weber's force? When there is no motion between the interacting particles, when the relative velocity and the relative acceleration are zero, we return to the laws of Coulomb and Gauss. So the whole of electrostatics is there. Weber's force complies with action and reaction. Only for that reason we have conservation of linear momentum with Weber's force. Moreover, Weber's force is along the straight line connecting the two interacting particles. Therefore, we have conservation of angular momentum as well. 2 years later, in 1848, Weber was able to find a velocity-dependent potential energy, which is presented here, which is the Coulombian energy, 1 over R, but which has a complement, which depends also on the relative velocity between the interacting particles. And then he was able to show that there is conservation of energy in his electrodynamics. So the 3 basic laws of conservation of classical physics are valid in Weber's electrodynamics: linear momentum, angular momentum, and energy. Next, please. So Weber wanted to deduce the Faraday's law of induction, and he succeeded. I won't go into the details here. For any of you who wish, you can look at Maxwell's treatise on electricity and magnetism. The last chapter of Maxwell's treatise is devoted to Weber's electrodynamics. And then Maxwell shows how Weber had deduced Faraday's law of induction with his force law. Also, the Ampere's circuital law can be deduced from Weber's force. Okay? So the whole of electrodynamics is there, but with no fields. We don't talk about electric field, magnetic fields. It is a completely different paradigm. Next, please. But to me, I discovered the Weber's electrodynamics because I always liked very much history of science. So one day when I was an undergraduate student of physics in Brazil, in a book of Whittaker on the history of electrodynamics, he mentioned Weber's force, and there was something in there which appealed to my physical intuition, which is what I call it is completely relational. It depends only on the distance between the interacting particles, their relative velocity and their relative acceleration. So it has the same value for all observers and in all systems of reference. It depends only on magnitudes which are intrinsic to the system of interacting particles. It depends only on the relation between the bodies. That may seem very simple, but nowadays, with Lorentz force law of classical electrodynamics, we have a velocity which depends velocity of the test charge relative to the observer. I never accept that because the charge is not interacting with me. It may be interacting with a magnet and so on, and so it should be relative interaction between bodies. And that happens in Weber's force and made me begin to work with that. Next, please. I won't go into many more details. 30 years ago, I did publish a book called Weber's Electrodynamics, 1994. At that time, it was published by a Dutch company, Kluwer. Then Springer bought Kluwer, and nowadays this book is available through Springer. So all the details of how can we deduce the law of Ampere, Faraday, and so on can be found in this book. So what I will go now is to begin about the main topic of today, which is Weber's planetary model of the atom, which is just fascinating. Everyone should know about that. So it has been completely eliminated from the textbooks. Next, please. Here I show one very simple drawing from one of Weber's works of 1852. Here is like a conductor, a copper wire, and then he supposed that we have positive charges which are fixed in the lattice, A, B, and C, capital A, B, and C. And then he assumed that a negative charge, we would say nowadays an electron, would make an elliptical orbits around the positive charges. So here are his words. As a result, the mass at small a will describe, for instance, an elliptical orbit around capital A, according to Kepler's laws. This supposition is at the origin of the Weber's planetary model of the atom. This is the first connection with Prague, because it was at this beautiful city of Prague that Kepler met the Danish astronomer Tycho de Brahe, and then they together, and then later on, Kepler, working on Brahe's measurements, he deduced the three laws of planetary motion. One of them is the elliptical orbits. So 400 years later, Weber was influenced by what happened here in Prague. Next slide, please. But he only in 1871, Weber solved the two-body problem, approximately, not in an exact, but very good solution. I will consider two situations here. The first one is when we have a positive and a negative charge. So they are charges of opposite sign, okay? So Weber's force is a central force, so there is conservation of angular momentum. The capital L, mr square over the angular velocity is a constant in time. No matter how they move, the angular momentum is constant. But Weber's law also complies with conservation of energy. So the sum of the kinetic and potential energies is constant in time. The kinetic energy K and Weber's potential energy U, which depends on relative velocity, that's a constant in time. With these two equations, we can obtain exact mathematical solution. Weber did obtain only an approximate solution, but everything was there already by Weber. Next, please. So, there is a general solution of this equation. I won't go into the details here, which based on the incomplete elliptic integral of the second kind. It's a mathematical expression, but very well known in mathematics. And the amazing fact, Professor Jan Rack knows that, is that the solution of this two-body problem, a positive and a negative, it produces the Kepler's elliptical orbits, but with precession of the perihelion. The ellipses, the axis of the ellipsis moves in space relative to the background of stars. And so that is quite fascinating. And already in the 19th century, Weber and other scientists, like the French one Tisserand, many years before Einstein, they were also trying to apply Weber's law to gravitation in order to deduce the known values of the perihelion of the planets around the sun. So Weber's equation is just fascinating. Everyone should know that in school. Next, please. But now, I will go to the most interesting portion of my talk today. We now will consider two particles with charges of the same sign. Can be two electrons, for instance, or two positive particles, like two positrons, okay? So Weber did also consider these two-body problems for two particles with charge of the same sign. This case presents the main difference not only with classical electrodynamics, Coulomb's force, scattering, elliptical orbits, and so on, but also the main difference with modern physics, quantum mechanics and nuclear physics. So now I will show to you that. Take your attention now, because that's very amazing result obtained by Weber. Next slide, please. So this slide 14 is the most important one of my presentation today. So I will go a little slowly because there is some mathematics, but they are very simple. So this was what Weber himself made in 1870s and 1880s. So 150 years ago. So he did simply apply Newton's second law of motion. F equals ma. Force equals mass times acceleration, okay? But what force did he utilize? His force law, which is Coulomb's law, velocity term, and acceleration component, equals to ma, Newton's second law of motion. Very simple. And let us assume that the relative velocity between the particles is small compared to light velocity. So we can neglect the middle term. And so we will have only two components, the Coulomb's term and the last one, which depends on relative acceleration. This r here cancels with the one of the r square here, and so this last component will be proportional to the acceleration of the test charge and falls as 1 over r. Okay? So Coulomb, a acceleration component, equals Newton's ma. Now we can take the second term, q1, q2, a over r, and pass this to the right-hand side, because both of them, they are proportional to the acceleration of the test charge. So we will have Coulomb's force equals the inertial mass of the test particle minus q1, q2 over rc squared. And a is the acceleration of the test particle. Now you can see, this is like Newton's second law of motion, but with a modified inertial mass. That is just amazing by Weber, because we can then control the inertia of electrons, and then that can have huge applications in electronics, nuclear physics, and so on. So Weber then asked, when will be this component here equals to 0? So m equals q1, q2 over rc squared. And this charge of the same sign, so q1, q2 is positive. So then we can put the distance here. So we obtain a critical distance in which that component, the effective inertial mass, goes to 0. If the distance between the interacting particles is smaller than this critical distance, this component is 1 over r. So this term will be larger than this one. So the effective inertial mass will be negative if they are very close to one another. So the particles will behave as if they had a negative inertial mass. Therefore, two particles with charge of the same sign will attract one another instead of repelling one another. Okay? For all of you who are watching this seminar, later on you give a look at this slide 14 at your home and write it down in paper, and you follow all these very simple mathematics but with amazing consequences. Next, please. So this solution originated Weber's remarkable planetary model of the atom. Because then, for instance, the negative charge, we would say nowadays the electrons, they would describe elliptical orbits around the nucleus, and these orbits would be elliptical but with precession. Okay? We can have 2, 3, or many electrons around the nucleus. And in the nucleus, inside the nucleus, we would have many positive particles which would attract one another, because they have, if they are at a distance smaller than the critical distance, because then they will behave with a negative inertial mass. So instead of repelling, they will attract one another. So they can be orbiting around one another in a very small nucleus. At Weber's time, no one knew about the electron and the positron, so he only obtained an analytical expression for this critical distance, but he could not estimate how large it was. He knew it would be very small, but he couldn't know because the electron was unknown. Next slide, please. But if we insert nowadays the known values of the masses and charges of two positrons, for instance, or of two electrons, we obtain that the critical distance in which they will begin to attract one another is 10 elevated to minus 15 meters, which Professor Jan Rax and every physicist know quite well. It is exactly the right size of the nuclei of all the elements. This cannot be a coincidence. This expression by Weber was obtained in the middle of the 19th century. The electron was later discovered and the positron only in the 20th century. But the value is there. Therefore, according to Weber's electrodynamics, two positrons, for instance, attract one another for when they are at distance smaller than 10 to minus 15 meters. So the size of the nuclei would be like 10 to minus 15 meters, and we can have 2 or 3 or many particles of the same sign together. Next, please. Weber wrote in the beginning of the 1880s his last major memoir on electrodynamic measurements. He has published 8 of them. The last one was published only after his death. He died in 1891, so the last one was published after his death 3 years later. It contained his mature planetary model of the atom. But already in 1871, in his 6th memoir, he already had all of these ideas. But I will quote here from the last one. So particles with charge of the same sign would attract one another when they were separated by distance smaller than his critical distance, RC. Weber called that in this case they would be what he called molecular motions, because they would be very close together. Weber said that they would form indivisible molecules, or the nuclei of his planetary atoms. He characterized these nuclei in a beautiful way by saying that this group formed an enclosed world for itself, due to the fact that the internal force connecting the two positive charges would be so great that it would be extremely difficult to break it apart. We can break it, but it will be very difficult. So he said they form a closed world in itself. His words, in quotation marks here, from 1880s, he wrote that. Additionally, not only 2 or 3, but a far larger number of similar electric particles, particles with charge of the same sign, could be together in such a small space, without the distance of any particle from another being greater than or equal than his critical distance, so that all of these particles together form an indivisible molecule which remains together forever. It is stable. This is fantastic, these words. Another sentence by Weber. Each such composite molecules forms an enclosed world for itself. Remember that this composite molecule or indivisible molecule is just the nuclei of the atom. So 2, 3, or 4 positive particles, and they remain together stable. Next, please. In the 80s, these are drawings by Weber, how he did characterize his planetary model of the atom. In the 80s, Weber tried to explain qualitatively the properties of the elements of the periodic table, utilizing his planetary model of the atom. He also tried to explain the chemical bondings between atoms. Also, everything with his force law. At the right, at the top, we have some of his models of the atom, many different possibilities. Our modern atom would be one of these possibilities, which I show here in the middle, one of the drawings by Weber with these square brackets. So this positive N would be the nucleus, and these any negative particles would be electrons moving around the nucleus. The modern atom with a nucleus composed of any protons surrounded by any electrons, describing elliptical orbits around the nucleus, corresponds approximately to the following Weberian, what he called a ponderable molecule, a molecule with weight at the right. I say approximately because Weber didn't know about the neutron, okay? That was just many decades before the discovery of the neutron and so on. This Weberian atom has any particles of positive charge and mass capital M attracting each other and moving relative to one another inside a very small volume, 10 to minus 15 meters, of diameter's critical distance. This stable positive nucleus is surrounded by any electrons, we might say, describing elliptical orbits around the nucleus. Orbits which precess, okay? Amazing. Next, please. I will just mention here three very remarkable, astonishing properties of Weber's planetary model of the atom. The first one is that it was a prediction in 1870s, 1880s. It was made before the discovery of the electron, 1897, before the discovery of Balmer spectral series of the quantized light, the lines of the spectra, which was 1897, and before the experiments by Rutherford, scattering experiments, 1911. The only model which appears in the textbooks is the Bohr model, 1913. But you see, Bohr's model, on the other hand, it was created, invented, in order to be compatible with these experimental findings. Bohr knew everything, and so he just made up a model which would yield these results, produce these results. But Weber, on the other hand, it was all in his head, based in the mathematical solution of his fundamental force law, Newton's second law of motion. Nothing extra than that. Next, please. Weber presented a formula for his critical distance, below which two charges of the same sign would attract one another. But he could not calculate its value, as the electrons and the positrons were discovered many years later, decades later, especially the positrons, 1932. When we nowadays utilize the modern values of the mass and charge of two positrons, we obtain that they will attract one another for distance smaller than 10 to minus 15 meters. Therefore, Weber's model gives a justification for the known size of the atomic nuclei, which was discovered only in the 20th century, many decades after, 100 years after Weber. But it gives the correct order of magnitude. This cannot be a coincidence. It must be the essence of the correct explanation of the stability of the nuclei. Next, please. In modern physics, it is necessary to postulate the existence of nuclear forces, for instance, by Yukawa, potential, and so on, in order to stabilize the positively charged nucleus against Coulomb's repulsive forces. Because when we have many positive particles together, they try to repel, and so the nuclei should explode. But they don't. So in modern physics that they postulate, oh, there is an opposite force, which is a fundamental force, nuclear force, which would stabilize against Coulomb. But if we go back to Weber's electrodynamics, we don't need to postulate these nuclear forces. Because in Weber's model, on the other hand, there is an unification of electromagnetism with nuclear physics, as the nucleus is held together by purely electrodynamic forces. So it was a unification before these two branches were separated, nuclear physics and electromagnetism. To Weber, they were already unified, and before everything was known. So this model should be taught at every physics and engineering school, but it has been completely forgotten. Next, please. For those of you who have an interest, in 2011, I published a book on Weber's planetary model of the atom in Germany with the people with whom I was working together. The late Herr Wiederkehr, which unfortunately is no longer with us, He was the main biographer of Weber, and also with Wolfschmidt, an astronomer. So we together, I worked with them in Hamburg, almost 2 years in 2001, 2002, and then an extra 3 months in 2009. And so this was one of the results of our joint work. So you can read that. It is available in English, in German, and in Portuguese. So now people can read these works. Next, please. And I would also like to call your attention that Weber's main works on electrodynamics have finally been translated into English. It is amazing, but this paradigm of Faraday, Maxwell, Lorentz, and Einstein's relativity, it dominated physics with such a pressure that the works of Coulomb, Ampere, and Weber were never translated into English, only in the last 10 years. But now, with the help of many colleagues like Professor Jan Rack and others, these works of Coulomb, Ampere, they are already translated, commented, and published in English, and also Weber's works. So, for instance, the second volume presents his work of 1846 in how he deduced his force law based on the laws of Ampere and Faraday. So 4 volumes have been published. The last one is on the conservation of energy, specifically on Weber's planetary model of the atom, and another unification of electromagnetism with gravitation, which may be in another opportunity we talk about that. That was also made by Weber. At the moment, I am working in Germany. I received a very kind invitation from Professor C. Liebach and Professor Frauenfelder. And since the end of September, I am working at Augsburg University with these 2 hosts. And they invited me with a Humboldt stipendium fellowship. And we are there working on trying to organize how will it be the 5th volume of the translations of Weber's works. So they were very kind to support me, and I will be there until the end of December. For those of you who are watching me, if you can do something which would be extremely important, just inform your colleagues and your students about the existence of these full and commented English translations of the works of Coulomb, Ampere, and especially Wilhelm Weber, because nowadays they are fully available with large bibliography in English. So everyone can read Weber's own words, see his beautiful experiments, how he did measure that constant c and found the same result as light velocity. Weber also deduced the telegraph equation many years before Maxwell, and he also deduced the wave equation together with Kirchhoff many years before Maxwell with his electrodynamics. So people should go back and read Weber's original works now, and also Kirchhoff. They are now available in English, finally. So these 4 volumes, for those of you who wish, you can download all of them. Also these works, these translations of the works by Coulomb and Ampere, freely from my homepage. And for those of you who wish, you can also buy these printed copies by Amazon, okay? But they are in PDF available in my homepage. Next, please. So, in conclusion, Weber's electrodynamics is extremely powerful. Conservation of linear momentum, angular momentum, energy, deduction of the wave equation, telegraph equation, measurement and introduction of the constant C, unification of nuclear physics with electrodynamics, unification with electrodynamics and gravitation, and also in connection here with Prague, because Ernst Mach, the Austrian famous physicist and philosopher, he was a professor here at Charles University, and he was also president of Charles University for some years. And Ernst Mach proposed a very deep, which is called nowadays Mach's principle, that the inertia of any body is due to interaction with the distant bodies in the universe. And if we, Professor Jan Rack invited me in 2019, I came here and gave a talk on relational mechanics, which is essentially an application of Weber's law to gravitation. Just introduce the velocity and acceleration component in Newton's force law, universal force law. And then we are able to implement, to deduce Mach's principle. So there is another connection with Prague, with Weber, and so on, which is just amazing. So many things come together. So Weber's planetary model of the atom presents a justification for the known size of the nuclei. It represents the essence of the correct explanation of the constitution of real atoms. We don't have all the answers, but the essence is there. And it stopped its development 150 years ago. We need to go on from now once more. It explains the instability of the nuclei with purely electrodynamic force. We don't need nuclear forces, UK or potential, nothing. This is the unification of nuclear physics with electromagnetism. In the last few years, there has been a renewed interest in Weber's electrodynamics due to novel experiments and new theoretical developments. Even Professor Jan Rack is planning some experiments related with Weber. We are in contact, and there are other people around the world making some theoretical developments, but also performing experiments on unipolar induction, superconductivity, effective inertial mass of electrons, and so on. So thank you very much once more, Professor Jan Rack and NAMI-Tech, for this very kind invitation. I have always been very happy here in Prague. I love history of science, and Prague is just beautiful and the right place to be, and very important for Weber. Thank you very much.
Thank you, Andre.